Imagine a world in our own solar system where rivers flowed, lakes shimmered, and perhaps even an ocean stretched across the surface. Today, it's a barren wasteland. Yet beneath its rusty crust, Mars holds secrets, possibly as much water as Earth's Atlantic Ocean, hidden away, frozen, or locked in rocks. Mars holds more water than we ever imagined, and understanding it might unlock the history of an entire planet, maybe even hints of life itself. Billions of years ago, Mars was a very different place. Evidence points to a time when it had a dense atmosphere, maybe thicker than Earth's, that allowed water to flow freely across its surface. Scientists believe that back then, temperatures on Mars were warm enough for rivers to cut through canyons and for lakes to pool in vast basins. Picture this: wide rivers meandering across plains, carving out channels in the rock while lakes reflected the red skies. But it didn't last. Mars's core cooled, its magnetic field faded, and as it lost that protective barrier, solar winds began stripping away the atmosphere. Without an atmosphere, the water began to disappear as well. Mars went from a potentially vibrant, wet world to the cold, desolate desert we see today. So, where is that water now? A large portion escaped into space, but a surprising amount is still on Mars today. Some of it is frozen at the poles, forming ice caps that look a bit like Earth's. But most of Mars's water is trapped underground, locked up in minerals within the crust. This is called hydration, where water molecules bind with minerals and stay preserved, even as Mars's tapped surface became hostile. And get this, scientists believe Mars could hold enough water beneath its surface to cover the entire planet in an ocean up to 1,500 meters deep. That's enough to bury half of Mount Everest. But because Mars has no tectonic activity, this water is stuck, hidden away for billions of years. There's another intriguing piece of the puzzle. Mars's water is rich in a form of hydrogen called deuterium, or heavy hydrogen. Deuterium has an extra neutron, making it heavier and harder to escape into space. Over time, the lighter hydrogen evaporated from Mars's atmosphere, leaving behind water with a much higher concentration of deuterium. This heavy hydrogen signature is like Mars's fingerprint, telling us that it once had oceans of water, but most of it drifted into space. Today, Mars' surface is harsh and unforgiving. Temperatures plummet to minus 140 degrees Celsius at night, radiation bathes the planet's surface, and its thin atmosphere is mostly carbon dioxide, with barely a trace of oxygen. Any water left on the surface either freezes instantly or vaporizes into the thin air. The Martian desert we see today hides what was once an oasis, buried beneath the sand, preserved only in memory. Despite these harsh conditions, Mars has something unique that keeps scientists curious: a history of liquid water. Water is the key ingredient for life as we know it, and every trace of water on Mars tells a story. In Jezero Crater, where NASA's Perseverance rover is exploring, scientists are searching ancient river channels and lake beds for any signs of past microbial life. They're looking for fossils, carbon compounds, or any ancient evidence that Mars was once alive. If life existed on Mars, even if it was just microbes, it might have left traces similar to those found deep within Earth's caves or in icy Antarctic lakes. As we dream about sending humans to Mars, understanding the planet's water becomes vital. Without a sustainable source of water, any Martian settlement would be impossible. But Mars' underground ice deposits might change that if we can find a way to extract them. One promising area is at the poles, where ice is most concentrated, but we need to go further. The idea is to drill into Mars' surface, mine its buried ice, and convert it into water for drinking, agriculture, and possibly even fuel. A future Mars colony may depend entirely on mastering this hidden resource, buried just below the surface. Recently, NASA's InSight lander detected over 1,300 Marsquakes, small tremors sparked by meteor impacts and hidden volcanic activity. These seismic waves revealed something astonishing beneath Mars' surface: a vast underground reservoir of liquid water. By analyzing these tremors with techniques similar to those used to study Earth's aquifers, scientists discovered signs of fractured, igneous rock filled with water, trapped deep within the Martian crust. These fractures likely formed as ancient magma cooled, creating intricate pathways for water to settle and remain hidden. But this water lies far beyond our reach, 7 to 13 miles below Mars' surface at depths challenging even on Earth. However, this discovery poses an electrifying question. If Mars has liquid water, could it also have life? Here on Earth, microbes thrive in extreme conditions, from the depths of mines to the darkest ocean trenches. Could Mars's underground waters hold similar secrets? If future missions could one day reach this water, it would completely reshape our understanding of the red planet. Mars makes us confront one of the most profound questions: are we alone? The search for life on Mars is part of a larger quest to understand the universe. Some scientists think that if life ever developed on Mars, it would suggest that life is common in the universe. But if Mars is sterile, then maybe life is rarer than we thought. Mars holds both the promise of companionship across the stars and the haunting reminder that we might be truly alone. If we could protect Mars from solar wind and rebuild an atmosphere, we might even restore these waters. We're talking about the tantalizing possibility of once again having liquid water on Mars, not just as droplets, but potentially as oceans and rivers waiting to be explored. And diving into these ancient waters could reveal the secrets of Mars's early history, perhaps even clues about life itself. So when we talk about the dry, dead Mars, it's only part of the story. Mars's water hasn't disappeared. It's merely waiting for a future where we might walk and maybe even swim through the mysteries of this long-lost ocean world.